These electromagnetic radiations are waves which are produced by the electric and magnetic field. We have atoms. These atoms consist of electrons and protons, which are charged particles. When these charged particles oscillate or vibrate, they produce acceleration. Accelerated charged particles produces electric field. These electric fields keeps on changing, and the changing electric field produces a magnetic field. These electric and magnetic field, they propagate through space in the form of waves, and this is how electromagnetic radiations are produced. The important properties of these electromagnetic radiations are the electric field and the magnetic field are perpendicular to one another, and these two electric and magnetic field is perpendicular to the direction of propagation of wave. You can visualize the propagation of electromagnetic radiation in the screen. As you can see, the electric field and the magnetic field are perpendicular to one another, and both are perpendicular to the direction of propagation. These electromagnetic radiations, they do not require any material medium for their propagation. They can travel through space. For example, if you consider sound waves, we know sound waves require material medium for their propagation, whereas these electromagnetic radiations can propagate without any medium. There are various parameters which define these waves, that is, its amplitude, frequency, wavelength, time period, velocity. There are various types of electromagnetic radiations based on its wavelength or its frequency. We can arrange all the different types of electromagnetic radiation according to the increasing order of wavelength or decreasing order of frequency. It is termed as the electromagnetic spectrum. Different regions of this spectrum have different names based on its frequency as well as wavelength. Wave nature of electromagnetic radiation clearly explains the two phenomena, that is, the diffraction and interference. Whereas wave nature of electromagnetic radiation fails to explain the nature of the radiation that is emitted by a hot body. It is nothing but it's called as black body radiation. Wave nature of radiation also failed to explain the ejection of electrons from the metal surface when a radiation is incident on it. Also, it failed to explain about the heat capacities of solid. It could not give any explanation related to the atomic spectra of hydrogen atom. The phenomenon of black body radiation was explained by Max Planck in the year 1900. When solids are heated, they emits radiation of wide range of wavelengths. For example, a iron rod which is heated, initially it exhibits dull red color, then it shows bright red color, then it becomes orange, and as the temperature increases it becomes white. Further, if we increase the temperature, that becomes blue. So, as the temperature increases, the frequency of the radiation that is emitted will decrease. If we consider an ideal body which emits all types of radiation and absorbs all type of radiation, it is named as black body. And the radiation that is emitted or given out by a black body is termed as black body radiation. The intensity versus frequency curve for a black body, it depends on the temperature. And you can visualize the graph here on the screen. From this curve for black body, you can visualize that the intensity of radiation emitted, it increases as the wavelength decreases and it reaches a maximum value at a point. Further, the intensity of the radiation decreases as you decrease the wavelength.